Today we will see how to obtain a reduction formula to evaluate the integral tangent nth power x dx. As always, we are going to start writing this as I sub n equals. Please note that I wrote I sub n, that is because tangent function is raised to the nth power. For example, if I have to evaluate the integral tangent 7 power x dx, we are going to start writing that as I sub 7. Alright, let's keep that in mind and proceed. We are going to rewrite this I sub n as integration. This time we are going to split this tangent n power x into two functions that are multiplied with each other, but unlike in sine n power x reduction formula derivation, we are not going to write this as tangent n minus first power x and first order tangent x. Instead, we are going to write that function as tangent n minus second power x times tangent squared x dx. The reason for writing it that way is because we know using the second of the three Pythagorean identities, we can replace tangent squared x by secant squared x minus 1. Remember, tangent squared x plus 1 is equal to secant squared x. That's the second of the three Pythagorean identities from trig. From that identity, we can subject tangent squared x as secant squared x minus 1. And after that, all I have to do is to distribute tangent n minus second power x term into each of these two terms inside the parenthesis. And then we will write this single integral as two separate integrations. Alright, let's do that. I sub n should be now equal to integration when tangent n minus second power x is multiplied with secant squared x term, we get tangent n minus second power x times secant squared x dx, and then I have this negative symbol minus another integration. Now I need to multiply tangent n minus second power x with 1. I get integration tangent n minus second power x dx. Alright, now we can quite easily evaluate this integral. Well, you may use a substitution such as u equals tangent x, but that's a little bit inefficient. We have seen a nice theorem in the past which says integration f of x raised to the nth power if it is multiplied by the first derivative of f of x. Let's say the first derivative of f of x is given by f prime x. F prime x dx is our integration to be evaluated. We know that this is going to be straight away equal to f of x raised to the n plus first power divided by n plus 1, where n is not equal to negative 1. We know that the tangent x differentiation is equal to secant squared x, and that tangent x function is raised to the n minus second power. So we can quite easily apply this theorem right here with fx being equal to tangent x, and instead of n we have n minus 2. Therefore, in the very next step we can write down the answer for that first part of the integration. That will be equal to, according to this right hand side, I have f of x raised to the n plus first power. My f of x is tangent x. The exponent n right here is equal to n minus 2 in our question. Therefore, it will become tangent n minus 2 plus 1, which is n minus 1 x divided by that same power, which is n minus 1. And then we have a minus symbol, minus, and then we have this integral, integration tangent n minus second power x dx. We are going to write it as I sub n minus 2. We are done deriving a reduction formula to integrate tangent n power x dx. Let's go ahead and use this reduction formula and see how to solve a given problem. Let's say I need to evaluate the integral tangent 7 power x dx. Since this power right here is equal to 7, we are going to write this integral as I sub 7 equals. Alright, then what we have to do is simply to apply this reduction formula right here with n equals 7. When we do that, we get I sub 7 equals tangent 7 minus 1 is 6th power x divided by 6 minus I sub 7 minus 2 is equal to 5. Alright, now I need to find I sub 5. In order to find I sub 5, I can reapply the same formula with n equals 5. However, because this I sub 5 is followed by a negative symbol, I'm going to write down all of that inside brackets. Let's go to the next line. I sub 7 should be now equal to tangent 6th power x divided by 6 minus, I'm going to open bracket, I sub 5. I'm going to use this identity right here with n equals 5. Then it will become tangent 5 minus 1 4th power x divided by 4 minus I sub 5 minus 2, which is equal to 3. Before reapplying that identity, in order to solve for I sub 3, we will do some simplifications. Now I sub 7 should be equal to tangent 6th power x divided by 6, and then do not forget to distribute this negative symbol into each of these two terms. Therefore, the next term becomes minus tangent 4th power x over 4, and then this sign right here, because of the negative symbol outside, becomes positive, plus I sub 3. Alright, right here is the formula that we need. Now I sub 7 should be equal to tangent 6th power x over 6 minus tangent 4th power x over 4. Then I have plus I3. Because this sign is a plus sign, I do not need to write down I sub 3 inside brackets. So I will simply ignore brackets and write down I sub 3 using the formula right here with n equals 3. Then it will become plus tangent 3 minus first power is second power x divided by 2 minus I sub 3 minus 2 is 1. Alright, now we are almost done. We know that I sub 1 is the integration of tangent first power x, which is a well-known integral. Therefore, in the next line, we can write down our answer. I sub 7, or in other words, integration tangent 7 power x dx should be equal to tangent 6th power x divided by 6 minus tangent 4th power x divided by 4 plus tangent 2nd power x divided by 2 minus integration of tangent x, which is equal to natural logarithm secant x. And of course this is an indefinite integral, therefore we need a plus c, where c is an arbitrary constant. Alright, that's it about this question. If you would like to apply this method and try a homework question, I would like to give you one. Evaluate the integration tangent 8th power x dx. Alright, if you need any help, please feel free to let me know. I hope you enjoyed this video. Thank you so much.